is an Erlenmeyer tube. Inside is a hydrochloric acid solution. A cube made from calcium carbonate is inserted into it. Not long after that, a number of bubbles emerged from the surface of the cube. From the chemical reaction equation, these bubbles are none other than carbon dioxide gas. Thus, the presence of bubbles in the tube indicates that a chemical reaction is taking place. Chemical reaction between calcium carbonate and hydrochloric acid. Now, cubes with the same volume or mass are divided into parts. 8 parts and 64 parts. Each cube is put into a different Erlenmeyer tube. It turns out, the number of bubbles that appear every second is not the same. Cubes with a smaller size apparently produce more bubbles. Conversely, the largest cubes produce fewer bubbles. How to explain this? A surface is microscopically composed of a number of atoms. So the atoms that carry out chemical reactions are the atoms on the surface of the cube, not those inside the cube. Currently, there are around 152 atoms on the surface of the cube. Now this cube is divided into 8 parts. Well, now the inner atoms become the new surface. The number of visible atoms is about 208 units. This means that Cuba can bind 152 atomic units of other reactants in 1 second. And Cube B can shine 208 atomic units of other reactants in 1 second. This is what causes the number of bubbles to increase if the size of the calcium carbonate cube is reduced. Because the surface area is getting bigger, there will be more and more atoms that react chemically. Hopefully this tutorial can provide useful benefits. And don't forget to like, share and subscribe.